In traditional and non-agile organizations, when we would estimate work, the unit of measure we would use would be time. Hours, days, weeks, months. And if you're anything like me, you're pretty lousy at estimating in time. Why are we so lousy at estimating in time in general? Why are we lousy at it? Well, the best way to explain why would be to give you an example. Let's say that my boss comes up to me and says, what is your estimate for this group of work over here? I think about the work and I think about all the things that need to get done in order to complete the work, and I start kind of going through the tasks in my mind and adding up the time each of those tasks is going to take. And let's say I tell my boss the estimate is 8 hours. The mistake I've already made is that I'm making the assumption that all 8 of those hours are going to be of a similar level of productivity. It's highly unlikely that that will be the case. And there are a million reasons why one of your hours may be less productive than you had hoped. They could be things like production fixes or last-minute meetings or interruptions of people just coming and talking to you. Or it could be other things. It could be personal matters. It could be some tragic news from a family member, or even great news, or perhaps you're not feeling well today, or maybe you didn't get a lot of sleep last night and you're kind of tired, or you're sick or something. Maybe you're out of coffee. It could be something as simple as that. All of those things can affect productivity dramatically. And all the things I just mentioned and the many others that I didn't are not predictable. That is why estimating in time, at best, is problematic. At best. At worst, wildly inaccurate. Now, you can play the game if you want of buffering those estimates and trying to account for that which is unpredictable. You're still not going to get any closer. Trust me, been doing it my whole life, or trying to do it my whole life, and never once got it accurate. Agile has another way of estimating. This other way is also not perfect. But the one thing it has going for it is that it's not based on time. It's relative estimation is what it's called, and it's not based on time, it's based on effort level. Let me give you an example of how it works conceptually. Let's say you're standing in a department store parking lot, and in that parking lot you look out and you see an 18-wheeler truck with a big trailer on the back of it. And parked right next to that 18-wheeler, you see a Toyota Prius. Could you quickly tell me which one was bigger? Guessing the answer is yes. You would definitely know the tractor-trailer truck is bigger by a lot. And I'm guessing with a little bit of study, you'd be able to tell me roughly how many Priuses could fit in the trailer of that truck. If the Toyota Prius in this case represents one story point, and you deduce that you can fit 8 of them in the trailer, then the trailer would get 8 story points. It's 8 times bigger. Now, when developers are using this technique, they're not considering the physical size difference between 2 objects. What they are considering is the difference in level of effort it will take to get the item to meet the definition of done. So let's take, for example, user story A. Developers are looking at it as a team, and they determine, first of all, there's not a lot of tasks with this piece of work, maybe 3 or 4 different tasks needed to get it done. So therefore, the volume of work is low. The second thing they're thinking about are the tasks themselves. Are they complicated, complex, or simple, straightforward? And let's say if they think they're simple and straightforward, then complexity would be low. So far, low volume, low complexity. And with those tasks, are there any inherent risks? Are we talking to dependent systems? Are we touching mission critical data? Are we touching parts of the code we're not aware of? Let's say in this case, they determine the risk level is extremely low. Straightforward work, they know exactly what they're going to do and how they're going to do it. And then the fourth thing they're going to consider is uncertainty. Do I know how I'm going to do this? Am I certain about the requirements? In this case, uncertainty is low, so this is a very easy story we've just analyzed. So therefore, we're going to give it a low point number, 1 point, let's say. Now they're going to story number or letter B. And in story B, there's about 30 tasks that they've identified to get it done. So therefore, volume is much higher than story A, volume of work. Some of those tasks are pretty complex. There's a lot of fine-tuned coding going on, lots of dependencies and things they have to be careful about. So complexity is high, and for that same reason, risk is higher. And there's a bit of uncertainty as to how we're going to do the work, and maybe some uncertainty around the actual requirements. So much more effort to get story B done than story A. When they compare the two, they determine that story B is about 8 times harder. So therefore, if story A got 1 point, story B now gets 8. That is how developers do this. And to take this further, what I'm going to ask you to do now is watch the video called What Are Story Points? That video is in the description of this lesson. I'd like you to pause this video, watch that video, and then come back. So go ahead and pause now and watch the What Are Story Points video by Cohn. Okay, so you saw the video from Cohn, and he reemphasized the fact that 4 things matter when determining level of effort: volume of work, complexity of the work, any risk in doing the work, and any certainty or lack thereof with regard to how we'll do the work or the requirements of it. To show you how to do this in action, I'm going to introduce you to a sizing technique called affinity sizing. Now, to be clear, this technique is not one I would recommend for novice teams just getting used to this idea. This is for teams that are a little bit more advanced. But I want to show you how volume, complexity, risk, and uncertainty all factor in when doing estimation. What we've got here is a canvas we're going to use for this exercise. 2 margins. The left-hand margin is labeled less effort, the right-hand margin more effort. And what we're going to estimate here in this exercise is the effort involved in reproducing these 6 shapes by hand. They're rendered digitally, but we're going to estimate them based on having just a pen and a piece of paper to reproduce these shapes exactly as they appear digitally. Okay? So how this is going to work, I'm going to take the first shape and place it somewhere in this canvas. Doesn't matter where. Then I'm going to take the next shape and compare it to the first one. And I'm going to be looking at the 4 factors that constitute effort: volume, risk, uncertainty, and complexity. And I'm going to be placing shape number 2 either to the left of the first shape if I think it's less effort, to the right of the first shape if I think it's more effort, or perhaps beneath the first shape if I think the level of effort is the same. So let's do this. I'm going to put the circle in the middle because I don't have anything to compare it to. Now the minus sign. If I compare the two, I think right away creating a perfect circle is hard. I'm probably going to have to do it over again several times with just a pen and piece of paper to get it right. Whereas the minus sign is a straight line, I actually think this is going to be significantly less effort than the creation of the circle. So that's how this works. I'm going to place the minus sign to the left of the circle, and notice I put a gap. This is because I believe the minus sign is not just easier than the circle, it's significantly easier. If I take shape number 3, the triangle, first thing I'm going to do is compare it to our minus sign here. Right away, I notice one very distinct fact. The minus sign has 1 line. The triangle's got 3. So that means the triangle has much more volume than the minus sign. There's more to do. But as I look further at the difference between the 2 objects, the triangle also is an equilateral triangle. That means all 3 of these angles must be identical. With just a pen and a piece of paper, that's going to be challenging. I might have to redo this many, many times before I get the angles exactly correct. So right away, I'm going to say the triangle is far greater effort than the minus sign. So now I'm going to compare it to the circle and ask the same questions. Now, here, volume still favors the triangle. It's 3 lines versus 1 fluid motion. However, creating a perfect circle is difficult. Is it more difficult than creating an equilateral triangle with just a pen and a piece of paper? Don't know. But here's what I do know. I can reproduce multiple examples of the circle much, much faster than multiple examples of the triangle. So therefore, the volume is going to increase with the triangle because I'm probably going to have to do multiple attempts to get it just right. So for that reason, I'm going to say the triangle is slightly harder than the circle in my opinion. So as we go down here, the next shape is our arrow. And for all the same reasons, much harder than the minus sign, still harder than the circle. But now, because of the sheer volume and number of different angles here, I'm going to say that the arrow is significantly harder than the triangle. If I go down here to this next one, the thundercloud, this one looks like it's got a lot of minuscule details that will really be tough to reproduce very accurately quickly. So for me, lots of risk, lots of complexity, lots of volume, and some uncertainty as to how I'm going to actually do it. So therefore, that becomes now my hardest piece of work so far. Last one is our right triangle. And while I do see differences in the right triangle versus the equilateral triangle, I think there isn't a significant enough difference to put it in its own column. I feel like these two are close enough where I can just put them in the same column together. And in the span of just a minute or two, I have now lined up, easiest to most difficult, 6 different pieces of work. Consider these in this example as product backlog items, okay? So now the question becomes, since I've got them all lined up smallest to largest, how do I now quantify them with story points? Well, there's a number of different numerical sequences you can use for your story point measurements. I prefer this one. It's called the Fibonacci scale. You probably heard of it before. It is not required that you use Fibonacci. I use it for 2 reasons. 1, I like the interesting gaps between the numbers as the sequence gets larger. And 2, I like saying Fibonacci. Those are the only 2 reasons I use it. You don't have to. Some teams I've worked with prefer t-shirt sizing. Small, medium, large, extra large. The numbers they typically equate to those are small is 1 point, medium is 2, large is 4, extra large is 8. If that works for your team, great. I've seen other teams just use 1 to 10 in single step increments. That's fine too, if that's what works for your team. The only cautionary note is whatever scale your team does use, they have to stick to it every sprint. Otherwise, the estimates will get all out of whack as you go further along. So we're going to use Fibonacci here as my scale, and we're going to decide how many points get assigned to these items. Here's how you do it. Go to your smallest item first. And as a team, you would ask this question, is this the smallest piece of work we can possibly imagine? Whether it's on our board here or not, smallest piece of work we can possibly imagine. If the answer is yes, great, this becomes 1. And now we're going to size all the other ones relative to this one numerically, okay? If, however, you can identify something smaller, let's say the team says, oh, wait a minute, a dot. A dot would be smaller than a minus sign. Okay, great. Then 1 goes over an imaginary column where the dot would be. And now the question is, how much bigger is the minus sign than the imaginary dot? Let's say the team thinks twice as much effort than the imaginary dot. Great, then the minus sign gets 2 points. Now, sizing the rest of these becomes how much bigger are these other items to the ones we've already sized. So let's start first with the circle. I can tell you that if it were me, I would think that the circle is more than twice as much effort as the minus sign. Twice as much would be 4 points, but that's not available on our scale here. So I'm going to go to the closest thing to it, which is 5. Okay, and just for sake of cleanliness, I'm going to put the 3 here over the empty column. Okay, so I'm saying so far, minus sign is 2, circle is 5. Now, what about the equilateral triangle? Is it less than twice as much effort as the circle, or is it more than twice as much, or some other number? My estimate would be a little less than twice as much, or 8 points. So now I'm saying the right triangle is an 8-pointer, as is the equilateral triangle, also an 8-pointer. And if I apply the numbers in similar thinking as we go, we'd land on 13 and 21 for the remaining 2 items. And that is how affinity estimation works and how we can apply numbers to them very quickly. Are these estimates going to be a guarantee to be accurate? No, because they're called estimates. They're not called facts. Estimates are always going to be a little off. That's okay. Close enough is good enough. The important thing is now we have something to work with. So the next question I would wonder about is, What number here in this scale indicates that a piece of work is too big for us to finish in a single sprint? That number is going to vary from team to team. The very first team I was ever a Scrum Master for, 21 was our limit. We could take in a story or a piece of work 21 points and under. Anytime a story was going to get bigger than 21, we had to split it because we knew we couldn't do it in a sprint. How did we find that out? We attempted a 34 and we didn't finish it. So we learned 34 or above has to be split. Then we attempted a 21 and were able to finish it. That's the only way to find out, trial and error. Now, the key for you as a Scrum Master here is you need to create a culture where the company understands that some level of failure is okay in order for us to discover these boundaries. Okay, that's oftentimes a hard sell, but it's necessary. I've seen other teams where the biggest story they would take in is a 5 or an 8. I've seen it vary all over the place. So every team is different. They need to find their own boundaries. Okay. Now, what if team number 1, my team, said that the circle is 5 points, but there's another team out there that also has a circle in their backlog and they said that the circle is 2 points? Can we compare their estimates to our estimates? The answer is no, because our estimates are driven by our personal experience and our personal capabilities. If that other team that had a circle and they said it was a 2 had done circles before, maybe they've had a chance to practice it and get good at it. So maybe their estimates are based on the fact that they've had practice and we haven't. We can't compare estimates between teams. And for that matter, we shouldn't compare velocity between teams either. And here's a brilliant example of why that is the case. Let's say that we've got a product backlog item, the same item for 2 different teams. The item is slam dunk a basketball on an NBA rim, NBA regulation rim. And on one Scrum team, you've got Michael Jordan, LeBron James, Charles Barkley, Shaquille O'Neal, and Magic Johnson. That team is probably giving that item 1 point. Okay. Now, another team has that same product backlog item in their backlog, and that team consists of me, a 5'8", 52-year-old Scrum trainer, and 4 peers that are just like me. We are going to estimate that PBI significantly different than that team of NBA legends. We're giving it the biggest number we can find, 55 points in all likelihood, or bigger if we can come up with a bigger number. Okay. Now, what if over the span of 2 weeks, a 2-week sprint, me and my 4 52-year-old 5'8" Scrum trainers all figure out how to do that piece of work and get it done within that 2-week time frame? We just got 55 points for it. Michael Jordan and his team only got 1 point for it. So if we're comparing velocities from team to team, clearly that must mean that my team is 55 times better at basketball than Michael Jordan and his team. The answer to that is no way. Okay, so that is why we need to educate leadership that comparing velocities between teams is a fool's errand. Now, there's another method of estimation that I want you to check out now. I want you to pause this video and check out the video from Mike Cohn called Planning Poker in the description of this lesson. This video, it's about 5 minutes long-ish, and it shows a whole other way of estimating that teams that are not yet used to this concept can easily put together and use effectively. So check that video out. And a couple of points on it. Once you're done with that video, come back to this one. I've got some parting words for you, and also a couple of things for you to download, and then a quiz. So go ahead and pause this video now and check out the Planning Poker video by Mike Cohn. Okay, hope that was useful. A couple of takeaways I want to share with you about planning poker. It's very important that we share the number at the same time, okay? The reason why we do that is because we don't want the developers to be influenced by other developers. So if you think that's a 5-point story, put that 5 up to your chest, and on 3, reveal it, and let the cards fall where they may. The value of planning poker is the conversation itself. If someone has an opinion that a story is 13 points and another has a story point of 2, well, one of them might know something the other doesn't. That conversation needs to happen to bring everybody into alignment. But the great thing is the rest of the team gets to hear that conversation too. So all of us are learning simultaneously. I've got 2 different downloads for you on estimation. One is a planning poker user guide, and the other is an Affinity estimation facilitation guide. Both of those will emphasize what you've learned here and help you practice it. I highly encourage you to download it and check it out. And now, as this lesson ends, please continue to the final lesson in this course, the quiz, and test your knowledge and make sure you've retained all the stuff that's important enough to retain. Thanks for being here. I appreciate you, and I look forward to crossing paths in the future.